So now I'm going to try to add this picture. And I want to look at the gorilla karyogram that we were looking at in class today. Gorilla karyogram. Awesome, it's going to work.
Oh, okay.
All right. So, like I said in class today, we've got how many double helices there?
4 double helices.
Yes. Okay. And despite the fact, so this is gorilla.
Yeah.
They're kind of like humans. In fact, they're very similar to humans because they're relatives of ours, if you want to agree with me. They've got 2n equals 48.
Oh, okay.
They're not 2n, so human 2n 46, they have an extra autosome pair. So we normally have 22 autosomes, and then the X and the Y, they have 23 autosomes, and then X and the Y. So they're 2n equals 48, not 46. So that means they've got 24 pairs. So 4 times 24. How many molecules of DNA are we looking at this entire picture?
4 double
That's
helices?
96. Yeah, that's 96 double helices.
Okay, yeah.
So right now, so this is the point I'm trying to make. We know that this is a species with a diploid chromosome number of 48.
Mm-hmm.
Right now we're looking at 96 chromosomes.
Yes, 96 double helix.
Yes, which
It's
I
the
use
same
as
thing. Okay, yeah.
chromosome double helix, but yes, I'm glad you agree with me there. So this is an essential point, and I'm glad that you're asking. I'm sorry that you're confused about it, but I'm glad you're asking. This species has a diploid chromosome number of 48. We're looking at 96 chromosomes right now.
Yeah.
Why is that?
Well, each one, it's like each little thing, it's a chromosome basically.
So this...
No, that's 2 chromosomes.
Exactly.
Exactly.
Yep, that's 2 chromosomes. And those, if we blow that up, that's chromosome 1 from mom, 1 from mom, 1 from dad, paternal, 1 paternal.
So, like, all the explanations of genetics are kind of like super confusing because they say for each pair you have 2 pair of chromosomes, 1 from mom and 1 from dad.
Right.
But
now we've got 2 from mom and 2 from dad.
Exactly. So it's not okay to say 2 pairs from 1.
So here's...
We actually have 4 pairs of chromosomes.
Here's the answer.
But the books show it as an X is 1 chromosome.
And we're going to, in fact, not next class, but the class after that, I think, we get into this exact point. But I'm happy to
mitosis, cell cycle,
yeah,
right?
exactly. Happy to get into it with you now, though. So during
There's G1 and
during G1,
it's the first
we're
growth.
diploid.
Yeah.
And if you look inside the nucleus, there will be... I'm trying to decide whether or not to do this accurately or not. During growth phase, the chromosomes aren't condensed into those objects that we think of as chromosomes, so I'm going to draw it as a blob.
Okay.
So there's chromosome 1, the paternal copy.
Mm-hmm.
And over here, there's going to be chromosome 1, that's the maternal copy.
Mm-hmm.
So we're diploid.
Yeah.
What happens after the next phase of the cell cycle?
You have to double it.
Right, so we've got synthesis, that's duplication. So then if we look immediately after S phase, at that same nucleus,
You have 2 from dad and 2 from mom. And that's the part where people do the karyograms from.
not yet, but you're right. This is why temporarily we've got 2 copies of 1 from dad, 2 copies of chromosome 1 from mom. So we're temporarily tetraploid.
Yes.
So here in the cell cycle, we're diploid. We
Yes.
become tetraploid, and then after cell division, I'm not showing G2 phase. G2 phase is in there. Then at mitosis, what happens is the 2 chromosome 1s from dad condense and they line up next to each other.
Okay.
And the 2 copies of chromosome 1 from mom do the same thing.
Okay.
And then we have cell division.
Yes.
So what happens is...
It's one dad, one mom, and one dad, one mom.
Right. One P, one M. And then the
Yes.
chromosomes... So that one cell then is diploid again.
Exactly.
And the chromosomes decondense, and then we're back to that situation.
Okay, so
it's only after it's only in mitosis.
Yes, in the karyographs, to show them in the karyographs.
Yes.
But a normal person would only have 2 pairs of chromosomes, which would be one from mom, one from dad.
One pair, yes.
One double helix.
Yep, that's what we've got here.
So we would have normally, without doing the karyotype, we would have like this and like this.
Exactly.
And that's why it would be 2 pairs of chromosomes.
Yes.
That's why I got confused, because in the karyotype you saw, and it was like, okay, if you count, there's not a pair of chromosomes, there are 4 pairs of chromosomes, so that's why I got confused.
Right. Yep.
That
So you
makes
only see 4 homologs
during
mitosis.
But normally it is like this.
Otherwise, you have
okay,
2 copies
yeah.
of the chromosome, the rest of the cell cycle, and that's why it's important to know simply that geneticists happen to have said it's going to be before synthesis. I didn't do this was agreed to well before I was born probably, agreed that it was going to be pre-synthesis cells where we count the number of chromosomes and decide, are you diploid, tetraploid, octoploid, whatever. And we just then know that after synthesis, it'll be twice that until cell division occurs, and then we're back to where we started.
So in mitosis, we're tetraploid.
Yeah, temporarily.
Well,
That's this drawing that you've got right
exactly.
there. Yep.
Okay, so all our karyotypes show that basically we are tetraploids. Then I'm not that confused.
No, exactly. It's all semantics and nomenclature.
Yeah,
and
that's why I was like, okay, normally
Yeah.
I thought of 1 pair, 2 pairs, that make 2 pairs per each.
Right.
1, 2, 3, whatever.
Yeah.
But then after seeing today, I was like, no, then we're like tetraploids. But, okay, that
Yes.
makes sense. I was watching your video of the sales cycle. I know it's like a bit farther.
That's okay.
And it said you made the 2 charts.